Every team building an AI product right now eventually walks into the same trap. They try to build a feature that is highly intelligent, lightning fast, and dirt cheap to run. But because these three vectors pull in opposite directions, you cannot maximize all of them at once. This conflict is known as the AI trilemma. Attempting to force a single model to be the smartest, the fastest, and the cheapest simultaneously is a primary cause of product failure. Today, we will break down a three-step framework to map your specific AI feature to the perfect operational model. Then, we will look at three engineering tactics used to navigate the strict constraints of the trilemma. Mastering these trade-offs determines whether an AI product scales profitably or crashes the moment it leaves the testing environment. Let's map the constraints. Take a moment and bring a specific AI feature you are currently building to mind so you can route it through this framework as we go. Our first vector is quality, output correctness, reasoning depth, and avoiding hallucinations. Next is latency, measured by time to first token, or how quickly a user sees the initial response. Finally, cost, the API token expense and compute overhead required per request. Because these three vectors are in direct opposition, your product's survival depends on intentionally sacrificing one of them to protect your core user experience. To make that choice, we categorize your feature into one of three operational archetypes. Archetype A is latency priority, where speed is the primary focus for interactive workflows. The strict rule is simple. If a user waits more than 400 milliseconds for a response, they will likely abandon the feature. To hit that target, the playbook requires deploying lightning-fast small language models, like Llama 3 8B, combined with aggressive prompt caching to drop response types. Think of this like a fast food drive-thru. For tasks like code autocomplete or voice assistance, the user accepts slightly lower output depth in exchange for an immediate response. Archetype B is quality priority. This applies when the cost of a mistake is catastrophic, such as in legal or medical fields. The playbook for this archetype involves routing requests to massive frontier models, like Claude 3.5 Sonnet, and using multi-turn agentic workflows that self-verify their answers. This is the brain surgeon archetype. For medical report summarization or legal analysis, a user will wait several seconds if it guarantees a result they can trust. Archetype C is cost priority. This profile is designed for high-volume, background processing tasks on products where speed is secondary to margins. Here, you sacrifice latency by processing tasks overnight using asynchronous batch APIs and heavily quantized models to slash token costs by half. This is the bulk cargo ship. When you need to mass tag an entire e-commerce catalog, you prioritize raw unit economics over immediate delivery. Applying the wrong archetype to your feature, like hiring a brain surgeon to work a drive-thru window, damages both your unit economics and your user retention. In practice, some products require high marks across all three vectors. When that happens, you must use specific architectural levers to navigate the trilemma's constraints. Our first architectural lever is known as cascading walls. This mechanic uses a tiny model to handle 90% of queries instantly. A router isolates the difficult 10%. Only these complex cases are escalated to a premium frontier model, ensuring expensive resources are used only when necessary. Lever 2 is UI masking, used when a slow, high-quality model is the only viable option for the task. You can alter user perception by streaming text character by character, which reduces the perceived time to the first response. You can also use microcopy animations, displaying status updates like searching internal documents, to keep the user engaged while the model processes. This is similar to placing mirrors in a slow elevator. Managing the human perception of time is often more cost-effective than purchasing faster compute hardware. Our third lever is fine-tuning. When a prompt requires massive context instructions to achieve high quality, the resulting massive token volume increases both cost and latency. The solution is to collect 1,000 perfect examples of the desired output and bake that logic directly into the weights of a smaller model. This is like memorizing a recipe instead of reading a massive cookbook every time you cook. It allows a small model to achieve high-quality results at a fraction of the original cost. By applying these tactics, the trilemma becomes a navigable engineering challenge rather than a rigid barrier. To execute, map real-time tasks to latency, high-stakes tasks to quality, and back-end tasks to cost. Align the product to the user's primary need first.
If you face a bottleneck, deploy routing, masking, or fine-tuning to maintain balance. Use the link provided below to continue mastering these AI product frameworks. Subscribe to the AI Product Management Playbook by Deepak Dio on LinkedIn for more in-depth strategies. Mastering these specific engineering trade-offs allows an AI product to remain both highly functional and extremely profitable at scale.